Good day, ladies and gentlemen, and my name is Robert Fanning, as you can see there. I'm working with Huawei Technologies. I'm based in Munich in Germany. So today I'm doing this presentation in English, even though I can speak a little French too. And my role is I'm working in solution development, solution innovation, and we have a number of teams in Munich. We have several hundred people, and we have one of our labs there as well, working mainly with new technologies, mainly NFV, which is there's a fair amount of open source components in it, SDN, and various smart city and IoT initiatives. So I'll begin, as I say, I'll try to keep it within 15 minutes, although I have to cut some slides out in order to do that. Only my glasses, where do I put them? Yeah. And so, a little bit of a history of if you don't know Huawei. They started not so long ago, 1987, by Ren Zhengfei, our chairman of Huawei, and he's still actively involved. And he started and he created a digital PBX system, and it grew within China, let's say over the next 10, 15 years. And then they started to expand abroad in developing countries, and then within Europe they made their first breakthrough in the carrier space. Let's say carrier getting involvement would have been the early 2000s. They got some contracts with Vodafone in Germany. They got involved in 3G and LTE, and then not so long ago, 4 or 5 years ago, we got involved in IT. So we have a big IT business now, making IT software, hardware, storage, distribution, and of course devices. So you're familiar with our devices now. They're starting to climb up and contend with the other big players. So at a glance, we can see that we have 170,000 employees. 45% of them, 76,000 of them, are involved in R&D. So we've a huge R&D focus and many R&D centers, both in China and in Europe, and we've one in Silicon Valley as well. So we have 16 R&D centers across the world, 31 joint innovation centers where we work with and collaborate with other partners, industry partners, whether they be in the IT area like Accenture, SAP, but also with carriers, and for the likes of, we have several projects with Deutsche Telekom, Telefonica, Vodafone, to mention a few. So we're ranked 228th by Fortune magazine. In terms of our growth, it's been quite staggering, to be honest. Sales revenue growth has grown year on year 20% over the last couple of years, with an operating profit of 12%. And that's going to increase by the looks of it this year. We've grown year on year for the first half 30%, operating profit of 18%. And so this is an amazing growth. A lot of this growth, of course, is coming from the carrier space, which is the growth in the need for broadband, mobile broadband primarily, with LTE 4G sales across the world. So we're a leader there. So our business is divided into three main, let's say, business groups. We have the carrier business group in the middle there, which we work strategically with many of the carriers around the world. We're working together with many partners in the enterprise business, and also we have a consumer business which is growing fast, selling devices and wearables. As you can see, smartphones has increased, mobile networks, fixed networks, enterprise networks, and data center infrastructure. More recently, we're getting now into big data analytics platform. We've developed a platform based on Hadoop. And we have offerings, private cloud offerings, private and public cloud offerings. So we're a global company. We have a global value chain, and this shows you where we're mainly based. Obviously, Shenzhen is the headquarters, but you can see there that we have many bidding centers where we're bidding on different tenders and stuff. We have supply centers. We have research centers. As I say, we have research centers there in Germany and also in UK. And so, move along. So, what is it we do? I guess our core business for the last couple of years has been RAN, which is radio access networks. We're providing the base stations for the mobile networks of the world. So there we have a number 2 position 24% market share based on revenues. We're also a huge player in IP routers. We are also number 2 in that, 21% market share, and this is growing. We are the leader in 400 gig IP routers, so the very, very large MPLS routers that you find in carrier networks, fixed and mobile carrier networks that basically transmit all the data across the network. And also we're leaders in WDM, which is the transmission transport, the optical networks. It's called Wave Division Multiplex. And also broadband access, we're also number 1 player. So the chances are that in most parts of the world you will find Huawei equipment sitting in cabinets on the street providing DSL, fiber to the home, or VDSL infrastructure. I think we're number 1, and I think Alcatel is the other player. In the radio, we're competing with Ericsson. And these are some of our carrier partners. Enterprise is growing rapidly. Again, number 3 in terms of the Ethernet market, and we're number 2 in China, the data center market. We're actually, in terms of volume of equipment sold, in terms of networking and storage, we are, I think, number 4 in the world. Okay, a lot of that is still in China, but it's growing rapidly in Europe as well. And again, here's another bit of something that has grown rapidly again in the last couple of years. Smartphone shipments have increased by 45% to 75 million. And I think total units sold, total units shipped would have been 138 of all types of devices, 138 million. So here we have some highlights of 2014. So what's driving our business now is essentially, as I mentioned, 4G. But we're now moving into a new era. So we're moving into IoT, and IoT has new network requirements. We're talking about billions of devices, connecting lots of devices, some with SIMs, some not with SIMs, and all of these have to be controlled, and will require new core network technologies. This is going to come out, let's say, in the next 2 years, and there's also new access technologies required to connect all these devices together heterogeneously, but also directly to the cloud, so have devices connected via low-powered wireless access systems. In smart cities, for example, we have developing a technology called narrowband IoT, which uses a very small amount of spectrum, is power efficient, it can deliver a 10-year battery life, and it can, most importantly, can penetrate buildings, indoor coverage. So rather than have to put special solutions, it can get an extra 20 decibels, can get inside the building, and can reach meters, parking sensors. So it will facilitate a much more rapid deployment in smart cities. So that's just, I won't go through everything there for time. And this is, so what are we looking for? We're looking for a more immersive experience. It's all about the user experience at the end of the day. It's all about real-time, on-demand, all online, the ability to customize and personalize your own experience, and of course, within the social environment of your families and friends. And this will need 4 main areas. We need ICT infrastructure to be faster, to be broader, and to be scenario-based. So we're not developing all the applications ourselves. We're developing the pipes, we're developing the enablers, we're opening our systems to APIs, and then we're developing the underlying SDKs and let's say some of the operating systems required to drive these networks. And they need to be real time, so we're looking at things like mobile edge computing, so pushing the content out farther into the base station, and so it, again, improving the user experience. It's all about the user experience nowadays. And then, of course, development of the devices, smart devices. So, as I mentioned, we're looking into an era of 100 billion connections. Some say within 10 years, potentially. Some say 50 billion within 5 years. We're looking at the advent of 5G, and 5G will require a whole load of new technologies, and particularly more spectrum. Spectrum in the air is a very, very finite resource. So we're looking at you've had one in France there last week. I think the 700 megahertz, but we're now looking at millimeter radio, so going really high up into the microwave frequencies to be able to get that really, really broadband experience, more broadband for the likes of, let's say, 4K video, but also car-to-car communications, so vehicle to infrastructure. Cars will communicate with each other to avoid accidents, to see up what's ahead, And this is all going on at the moment, and we are involved in another number of research projects in Germany as I speak with some of the car manufacturers. Cannot speak too much about it, but safe to say that we're going to have there's a plan to have connectivity from cars to infrastructure on some of the major autoroutes, autobahns in Germany. They've also got these trucks that can go very close together, completely autonomous driving. This is the future. I know it's probably you're probably looking at 5 to 10 years out, but the technology is there today. It's being tested. And this was my original presentation that I came here to develop, but I realized that it probably wasn't appropriate. We're developing a whole new architecture for the carrier, and it includes a distributed data center environment. So traditionally today, carriers will buy boxes from us and from Ericsson, from Cisco, that are purpose-built on ACA hardware, and the hardware is closely entwined with the software, and it takes a long time to swap out, to upgrade the network. With the new approach based on NFV and OpenStack, you can decouple the hardware from the software, so you can mix and match between software, between operating system, between and whatever. And this is the whole start of the section on open source. And apart from that, there's also the programmability. So the programmability is moving into the cloud. So typically today, like a router would have its own routing tables located in a router physically, and but now it's all being moved up into the cloud. So using OpenFlow protocols. Okay, so four pillars of Softcom is, of course, as mentioned, NFV, SDN, but there's also moving everything to the cloud. So we're looking at platform, creating the capability for carriers to be able to deliver their own services because their own revenues are declining. They're struggling, and they're also fearful of the OTT players. Many people predict that in a couple of years' time, many of the brands that we're aware of, not just in telecom carrier space, but also in the car companies, could disappear and be replaced by the likes of Google and Apple and these OTT players. So the carriers are fighting back, and they want to be able to offer their own services, to monetize their own network assets, open the networks to APIs, and this is the third aspect. And of course, the whole thing will be internet-based. So they need to operate their whole network like the likes of Google's. And as I said, we're doing some innovation here. This is a key to the future. We're investing 600 million. So what is 5G? So 5G, summarized, is basically infinite bandwidth, almost. So we're talking about, and billions of connections. So that could be high bandwidth connections, whether it's video cameras, surveillance cameras, or IoT devices. And to connect all these devices, today a cell site can typically handle maybe 1,000 connections, but now we're talking about 100,000 connections per cell site. And then we're also, so say 10 gigabits. So we've already demonstrated this in labs, the ability to, I think today now you get, there's the theoretical maximum, which is about, it's about a couple of 100 megs if you aggregate some of the carriers. And now we're going to a new era with millimeter spectrum to be able to deliver very, very high bandwidth. Okay, and this is and there's also the interconnectivity. So in the future, rather than everything going back to a network, devices will be able to talk to each other and make decisions on the fly. And also latency, this is a key factor. So today you might have 20 milliseconds latency. This needs to come down to 1 milliseconds. So we're doing research on that. And I think, how much more time? It's okay. So how do we build a robust ecosystem? So we're doing three types of innovation, let's say, together. We do our own fundamental innovation, which is all in-house. Then we do through strategic partners, allied partnerships, and then, of course, through the open source community. So without the strategic alliances, we're not going to be a player. We realize that without opening our networks, without being part of this open source community, we will just remain a box seller, and then we'll go down. So this is a fundamental part of our strategy. So we play an active role in standards organizations, like the likes of OpenStack. I'm going to move on. This is the second part. It's only a couple of slides. Just shows you what we're doing, color changes. So what have we done in open source so far? So I guess we embraced the concept back in 2008, and our team was formed. And then we joined, we developed our first cloud operating system based on Eucalyptus and Zen. We then got into the Hadoop community. I think now we are one of the top players in Hadoop. We're part of the Spark initiative, and we've actively contributed in the last couple of years. So we're a silver member of Apache, for example. OpenStack is a core component of our, let's say, our Fusion Sphere operating system, both for enterprise and for carrier, for the data center, and for the new core networks within mobile and fixed networks. We're part of Open Daylight, which is, there's a couple of projects ongoing to, let's say, help advance the adoption of NFV and SDN, and one of them is ONOS, which is the Open Network Open Source Forum, and then the other one is Open Daylight. So we're a founding member of ONOS, and we realized that we need to build a community in order to accelerate the adoption of NFV and SDN-based technologies. And of course, we're in part of the Linux Foundation, a platinum member there. So again, we're working both with, this shows you, a couple of different organizations. So for example, you've got the traditional ones there, like the ITU, the International Telecommunications Union. You've got 3GPP, which defines all the standards. So we work together with the standards, and we work also with the open source community. So there you can see, for example, Cloud Foundry. I think we're in the top 7 in Cloud Foundry, the top 4 in Hadoop, and then we're also a founding member of some other organizations. And again, we move on and we show our strong technical capability in the operating system. So this shows you just the resources that we're putting into it. So I think within the kernel of Linux, I think we're one of the top 20 contributors. So this is the future within Huawei. Another thing we're developing, this is for IoT, and it solves a number of issues: connectivity, interconnection between devices, security, power consumption, zero configuration where you don't have a user interface, and also remote control. So what is it? It's one of the lightest kernels available today. It's 25% of the footprint of any existing kernel. It has 20% of the consumption of any other, and has very fast response time. So there it handles, as I say, connectivity. You see there in the connectivity layer a couple of protocols. There's Zigbee, which is used within the smart home environment, and you have a thing called LTEM, which is this connectivity standard that we're developing, and that I mentioned earlier, for narrowband IoT communications. And this OS comes with SDKs and can sit in gateways and can sit on devices. But mainly this is for small, so to say, dumb sensors or devices. And then again, I mentioned OpenStack, which is based on standard open APIs. There's basic support for third-party products, and also it's software-oriented architecture based. So again, I think I mentioned that before, but we're not only, if you're familiar with OpenStack, there are a number of components there. Nova, which is compute, networking and storage, Nova Neutron Cinder, and every twice a year they have these updates. I think, I can't remember who the last one was, Juno, was it? But there's a new one due, and we are a big code, we've a lot of code commits. I think we're 6th in terms of feature contributions, and 9th in terms of bug fixes. But not only that, we're also building around around the OpenStack framework. And this is because within the carrier environment, you're carrying lots of traffic, you're carrying very sensitive data, you have huge amounts of data going through a carrier network, much more so than the enterprise environment. And it needs resilience, it needs high availability, it needs faster performance. As I mentioned, we need to get the latency down, and we're also developing these additions to OpenStack to make it more robust. Another is OpenNFV. This is also, we founded this as a Platinum member. This is also for developing NFV. And we have created labs around the world, open labs. So we're inviting application developers to come in and test whatever their products on our platform and with our operating system. Again, as you see, we have in Santa Clara, we have a big lab in Xi'an, and then we have Munich, where I come from. So basically, we have our whole architecture is layered in an open environment. So you can see in the bottom there, you've got the standard hardware, which is can be any hardware. We have the OpenStack operating system on top, and then we have the platform as a service. We're part of Cloud Foundry and OpenNFV. And then the independent services for big data, etc. And then we're also partnering with many players like SAP, SAP HANA, and Accenture. Finally, I just told you we're developing, because of the amount of, I think there's 2 million people involved, I think I saw a figure on open source around the world today. There's many activities, there's many projects. We're involved with many projects. So we developed our own insight tool, both to be able to track internally within our organization, which is huge, but also within the greater open source communities and all the different initiatives, the different projects. So this basically will help us track what's going on, what code's being released, what new projects are forming, and also not to be shocked. So it's a way to be proactive to the open source initiatives and communities around the world. So essentially gives you a snapshot of what's going on at any time. And this has proved to be very useful for us in tracking what's going on. And that concludes my presentation today. And thank you very much for your attendance. And then I think I can either hand over, unless there's any questions, or we can handle the questions afterwards.
Question anyone?